4 is the root, and the root is always in the denominator, right? So log of 27 to power 1/4 to base 3. And now that I have rewritten it, I can also say equals to x, because I'm told to solve. So I might as well make it an equation. Solve. So now I made it an equation because I'm told to solve. All right. So remember, this is final exam review. That's why I said I'm going to start recording it. Okay. So I can see that now that I have written it, let me see if I can change it to exponential equation. And when I change it to exponential equation, I will see if I can put both sides to the same base. So let's see. So 27 to power 1/4 is equal to 3 raised to power x. So I have changed the logarithmic equation to exponential equation. This is clear, right? Is it clear? Okay. Now I want to see if I can change both left-hand side and right-hand side. I want to see if I can rewrite them in such a way that they have the same base. You think so? Somebody tell me. I can rewrite this such a way that they have the same base. 27, yes, go ahead. 27 is the same as 3 to power 3, correct? 27 is 3 to power 3, so I can say 3 to power 3, then I can exponent 1/4, which is equal to 3 to power x. Then I'll continue right here. So that means if I open the parentheses, 1/4 will multiply. So I have 3 to power 3, 4 is equal to 3 to power x. You see, now I have succeeded in, not just me, we have succeeded in raising both of them to a power but the same base. And if I can change the bases to be the same, the exponents are equal. All right, so this is one of the properties of logarithm, an exponential function that we have to utilize always. So we are taking advantage of the inverse property of exponential and logarithmic function. Because they are one-to-one, they are inverses of each other, like we said the other day. So x is equal to 3/4. And I'm told to leave my answer in fraction. So I can leave my answer like this. That's all. Any question? Any question? So I can leave my answer like this. Do you understand? Okay. If you don't, let me know. So remember that you can always take advantage of the inverse properties of exponential function to solve a logarithmic equation. So that's number 29. Let's go to the next number. I'm going to clean a little bit. It's clear to everybody, right? All right, so let's go to the next number. Clean this one up. All right, so the next number, we don't have to do all of them. See, it's exam review. So we can do, so number 30, let's look at number 30. Evaluate the following logarithmic expression without using calculator. Write your answer as a fraction reduced to the lowest term. So let's go ahead and do what we need to do. All right, so I want to copy this function. And after I copy it, I rewrite it. So I'm going to, so this is what I'm given. So it is log 0.00004, 6 or 3. See how many zeros are given. Okay, so and I can put parentheses in there. That's all. I'm told to solve this. So I have to make it an equation. Now, by the way, I want you to see that there is no base. So just as a reminder, whenever there is no base, it is base 10. So let's put the base 10. If there is no base, it's base 10. Like we said last week, if there is a base that is not base 10, then you must do a change of base. Or do a change of base. So I want to rewrite is equal to x. All right, so then I will take advantage of the inverse properties of logarithmic and exponential function. So I can still say 0.0001 is equal to 10 to the power x. The next question is there a way I can make both sides have the same basis? You think so? I can, what do you think? Check it out. Check it out. Tell me if I can change the two bases to base 10. Are you looking? Anybody has an answer? Anybody has an answer? What can I do? Yes, go ahead. So I can change, I don't want to say what you, I'm not going to say, go ahead and say so we can hear you. Are you trying to say I can change 0.001 to maybe put it in fraction form? Is that what you want? Yeah, okay, well, so let me make sure so what I'm going to do now is I want to convert this. So let me actually, it's in decimal. So I'm going to count the number of decimal points here. So if I count 1, 2, 3, 4. Okay. So that really means that I can write this at 1 over number 31 says. Number 31 says, evaluate the following logarithmic expression. Well, this time is natural logarithm. Natural logarithm. ln, evaluate the following logarithmic expression without the use of calculator. Write your answer as a fraction reduced to lowest term. Well, a quick reminder that natural log, let me just show. Let's make sure we write that. Natural log of E, if you are talking about E, is the same thing as log, ordinary log of E to base, you see, natural log, if I have log E to base 10, then it's, I can make it natural log. Okay. And whenever, let's put it in let's put our calculator. Do I have my calculator here? Let's actually ask our calculator, what is natural log of E? Let's use a calculator and make sure that we know how to put it in our calculator. So it's on. Let me first of all ask my calculator, what is natural log of E? So this is natural log, by the way, everybody. ln is under logarithm. So I will look for E, and it's actually hiding somewhere, but I better find it. So I think it is right here. Not this one. Looking for E. Okay, it's under. So let me do that again. Natural log. Of E. Okay. And then when I put that up, I'm going to put to power 1, and I'll close parentheses. I'll close parentheses. Okay. So the natural log of E is what? According to my calculator, it is 1. So right now, today, from now on, I want you to remember that the natural log of E is 1. We shall not be evaluating it all the time. Natural log of E is 1. Let's also investigate what is log of E. What is log E? So log, if I put log here now, it means log E to base 10, right? Because my calculator does not know any other base for common logarithm. So I'm going to put log E like I did before, and I'll put 1 here, and then so what is log E? I want you to know that, again, that if I don't write a base, it means log E to base 10. Do we all agree? Because it's assumed that you know it. When you get to calculus, your teacher is not going to be, if you're going to take Math 111, which is trigonometry, they won't start asking you that. They think you already know it in algebra. But anyway, so if so let's see. So I put natural log of E. So what is it? So this is log E. So I want us to know this is log E. So we will not be using log E in place of natural log. So unless I do log E divided by log E. Okay, so I am going to do log E, and I want to divide that answer by log E. Okay, so divide by log E and see what happens. Okay, the reason why I divided it is that log E to base 10 is, you see, E and 10 are 2 different bases. So I found I did change of base. So I found log E divided by log 10. So log E divided by is 1. So anyway, the important thing is that whenever you are given natural log of E, it is 1. Natural log of E is equal to 1. It's important that we investigated it. Also, we need to investigate. Let's not use log. Let's just find E. Everybody, let's find E only. What is E without log? Want to know what is E without log? The exponential function without log. Are you looking? So, anytime you are given E to calculate, just know it's an exponential function, and it is 2.718. When you start doing calculus or pre-calculus, you will notice that sometimes they want you to use all the 9 decimal points. Okay? Want you to use, and E is an irrational number. Do you notice that the decimals are non-repeating, non-terminating? Do you notice that? The decimals are non-repeating and non-terminating. Therefore, E is an irrational number, just like pi. Okay, we want to also remember, they're all in final exam. What is an irrational number? Can you give an example? So we are going to get pi, another one that we need to remember. So where is pi? Second, pi right here. And I want to evaluate it. So look at pi. Pi is 3.14, but it doesn't stop there. It has 9 decimal places. The decimals are non-repeating, non-terminating. That's how we identify irrational numbers. Irrational numbers have non-repeating, non-terminating decimals. Okay. Non-repeating, non-terminating decimal. Let me divide something so you know. We divide 3. Okay. Suppose I have 3/6. 3 divided by 6. This is terminating. The decimal is terminating, right? Let me divide 1 by 3. We talked about this in Unit 1. Are you looking? If I evaluate 1/3 with my calculator, the decimals are repeating, right? This is how we know rational numbers. So 1/3 is a rational number. Why? Because the decimals are repeating. The decimals are repeating. So you should be able to differentiate rational numbers and irrational numbers. Show an example. Okay, because it's already in final exam. Okay, let's continue with logarithm. Let's continue. We're just making sure that the things we did in Unit 1, final exam is cumulative, like I said before. All right, so final exam is cumulative. So we have done. All right, so now the question here is natural log of 8th root of e to power 6. We're told to solve this equation. Solve the equation or evaluate the expression natural log of 8th root of e to power 6. So let's first of all copy that equation. Natural log of 8 of e to power 6. That's what I'm told to. That's what I'm told to evaluate. It's not an equation. So I am the one that to make it an equation because I'm told to solve. So I will say it's equal to 0. It's equal to x, not 0. Make it an equation. In other words, I will introduce a variable. And then I want to rewrite. So I'm going to rewrite first before I start. So rewrite, I have a natural log of e to power 6/8. Remember that 8 is the root. The root is always in the denominator. Do you remember? It's equal to x. All right. Now, remember one of the laws of logarithm says exponent is coefficient. So according to one of the laws of logarithm, exponent is coefficient. So the exponent 6/8 can be written as 6/8 multiplied by the natural log of e is equal to x. Still remember that? Yes. Okay. All right, so The next step is that we already know that natural log of E is equal to 1. We just saw it. Even our calculator testified with us. Natural log of E is equal to 1. So all I have to do is 6 over 8 multiplied by 1 is equal to x. So x is 6 over 8 or 3 over 4. So the value of x is 3 over 4 to the nearest form of fraction. Are you following? Any question? Any question? Okay. Well, just because we don't have any day to review, we come back from Thanksgiving, we start our exam. So we might as well use this time we have. Okay. So I'm going to clean this since you understand. You said you understand. We are not about to do all of them though, because not about to do all of them. We're going to do some, and then you will finish the rest. So we just did number 31. Let's go to another equation. Solve this equation. I think you can do this. I think you can do this. Okay. Okay, so you can do this, but anyway, let's do that. So let's do it. Let's go to 32. 32. So number 32 said that log x. This is log x to the 16. This time they gave us a quotient. So, write your answer as a fraction. Use the elementary properties of logarithm to solve the following equation. In other words, we're not using calculator. Another thing you want to do is remember that logarithm and exponential function have inverse properties. So change it from logarithm to exponential function. And the rest is history. So let's do that. So I can now say that x is equal to 16 to power. So x is equal to 16 to power 3 over 4. What does it really mean? This really means x is equal to the 4th root of 16 cubed. And then I can rewrite it. 4th root, this is 4 here. And 16 is 2 times 2 times 2, that's 8 times 2. Okay. Remember that, so I just wrote 2 to the power, and then I have, let me move it a little bit. Okay, so all these are cubed. All these are cubed. So if I want, I can actually repeat. Okay, let me repeat it. So I have 4th root. Okay, so I have 4th root of 2 times 2 times 2 times 2. Then, remember it is to power 3 times 2, 2, so that's okay, to power, and then times 2 times 2 times 2 times 2. All right, so I have made it into 3. Remember that this is 4th root, so I can actually count. So this, from here, 1, 2 comes out. From here, another 2 comes out. From here, another 2 comes out. Therefore, my answer is 2 times 2 times 2. My final answer is 8. Do you agree? My final answer is going to be 8. I spread it out, but I don't have to. Because if I actually do it another way, I can. Let me do it another way. Yeah, so if I count the number of 2's here, this is 4 plus 4, 8 plus 4, 12. So I can as well write it as 2 to power 12, 2 to power 12 divided by 4. And that is the same thing as 2 to power 3, 8. In either way, there could be so many ways you can do it. That way, if you do it right, your answer will be 8 or 2 to power 3. Any question? Any confusion? So you're going to demonstrate it on exam day and also demonstrate it on Unit 4 test. Unit 4 test will be on the 25th. Final exam will be as soon as we come back from. Okay, so that is okay. They want us again to use the elementary to solve this problem. So can we change the base? Yeah, can we get the basis to be 5? So let's see. So I am going to clean. So if I can change the basis, then all right, so what are we given? So we are given that 5 raised to power log x to base 2 is equal to 25. 5 raised to power x to base 2 is equal to 25. So the question is there a way I can raise both sides to base 5? Yes. So let's raise right-hand side to base 5. I have 5 raised to power x 2 is equal to 5 to power 2. So the bases are equal. Do you see that? The bases are equal. Therefore, the exponents are equal. The bases are equal, so the exponents are equal. Okay. And now, if log x to base 2 is equal to 2, log x to base, so I am going to so now I have log x to base 2. So I'm going to now say log x to base 2 is equal to 2. I still have to do exponential function. Do you have to leave early, sir? Okay, yeah, that's fine. So I'm going to change this again I'm going to change from this to exponential form again. I didn't know, did you hear what he said? Did he say he's going to leave early? I don't think anyway, but anyway, he's a good student anyway. So x is equal to, has been a good student anyway. So using exponential form, but I think he already knows this though, because I haven't returned the test where he didn't make 104. I have no, there's no test he has never made. Okay, so he probably knows it already. Anyway, so is this clear? Okay, I'm sorry, I forgot. Okay, that's all recording. Okay, I'm gonna cut this off. Okay. Um. All right, so let's keep on going. So provided you still remember the properties of logarithm. Let's see the one we see here now. We still remember the properties of logarithm. That matters a lot. So let's go to natural log again. We answered that question. Let's go to natural log. Solve the following logarithmic equation using a calculator. Say use a calculator this time. If necessary, to evaluate the logarithm, write your answer as a fraction or, okay, so this time we are told to use a calculator. We're actually told to use a calculator. Well, okay, well, let's try and solve it and see if we need a calculator. So we still remember that we can take advantage of the logarithmic and exponential properties. All right, so let's try and do that. This up. Can I see my whiteboard? Are you hiding it? All right. It's hiding somewhere. So, okay. Whiteboard is just disappeared. I can see it, but I cannot put it. Let's see what is going on there. Make it small and see. Is it going to appear now? Hopefully. Ready. Okay. All right. So now I finally found my whiteboard. So we're going to try and solve the problem. We are told to use calculator. So we'll try to do it algebraically without calculator first. So let's try to do it without calculator. Clean first. Okay, so the question right there says log to base 3 of 2x. No. Well, log to base 3 of 2x minus 1 is equal to 3. Everybody look. We can actually use exponential form. So log to base 3 of 2x minus 1 is equal to 3. Okay. First of all, I want to try the inverse property of logarithm. So I have 2x minus 1 is equal to 3 to the power 3. I want you to follow what I'm doing. And I'm going to ask you, when I finish, okay. Then, so the right-hand side is equal to 9, 3 times 3, 27, times 3 times 3 is 27, plus 1 on both sides. So we might not actually use calculator. 2x is equal to 28. Therefore, this implies that x is 14. What did you get? Is that what you have? Is that what you have? Look, is that what you have? So we actually got x equal to 14 without calculator. But for some reasons, they told us to use calculator. Anyway, if they tell us to use a calculator, you have to remember your calculator only understands log to base 10. So you have to change the logarithm, change the base, the left-hand side. But I don't even see why you want to use calculator. It's easier to solve without calculator. Okay, let's keep on. Let's keep on moving. Any question? Any question? All right. All right, so I'm going to move this up a little bit. Tell me when it is time. Okay, I think we can use 10 more minutes. We can use 10 more minutes and we go and get a break. Today is Thursday. I go and get a break. So let's do another one and we can. The one has natural logarithm. And then next week we do systems of equations. You know, that's the only thing. Systems of equation by substitution and elimination method. That we already know. Trust me, that we already know. Okay. So let's try, and I'm going to rewrite 35 and 36, and I'll let you finish it. Finish both of them. So let's rewrite 35 and 36. So for 35, we're told to solve the equation. It actually is clear this time. Natural log of 4x plus 2 is equal to 5, actually. Are you there? Okay, you following? Are you tired? All right, we'll soon finish. So I want to change the base. So let's rewrite the base. So I can write natural log of 4x plus 2. So you know, this is base E, right? It's equal to 5. Okay, I am going to use the exponential property of logarithm. So 4x plus 2 is equal to e to power 5. Do you agree? Yes, this, okay. So I can rewrite it this way. So now I'm going to solve minus 2 on both sides. And then I have 4x is equal to e to power 5 minus 2. And so x is equal to e to power 5 minus 2, all divided by 4. Even if you leave your answer like this, I'll take it. If you leave your answer like this, I'll take it. You can leave your answer in terms of e. But if you're told to leave your answer to nearest decimal, I mean, maybe nearest 10th, nearest 100th, nearest 1000th. Remember, the nearest thousands is 3 decimal points. Nearest 10th is 1 decimal point. Nearest 100th, 2 decimal points. Okay, one last example. And we call it a day. So the next one now is exponential function to base E. So this exponential function is base E. So we are told to solve an exponential function equation to base E. First one is to copy the question. Okay, so I have E to all right, so we have e to the power 3x, e to the power 3x is 11, is equal to 61 to the power 2x plus 2. So we have copied the question. And one thing you want to know is there is no way that I can raise 61 to have base E. No way. So this is a candidate for using the properties of logarithm.